Hello guys, I hope you are having a good time. Today we are going to start fluid mechanics, one of the most important subjects of mechanical engineering. My name is Rahul. You are watching Smart Tech Ed, where you can expect the best. So guys, without any delay, let's start our video. So guys, before going to the concepts and theory of fluid mechanics, we first need to know what is the syllabus of fluid mechanics. Fluid mechanics subjects includes introduction and fluid properties. The second is fluid statics, which itself have three parts, that is pressure measurement, hydrostatic forces, buoyancy and flotation. The third part is fluid kinematics, then fluid dynamics, then laminar flow, and further it has turbulent flow, flow through pipes, boundary layer theory, dimension analysis and vortex motion. As we all know, fluid mechanics is one of the important and crucial subjects for exams like GATE, PSUs, and other competitive exams. Fluid mechanics. Fluid mechanics is a branch of science which deals with the behavior of fluid, whether it is gaseous or liquid, at rest as well as in motion. Or we can say, fluid are the substances that are having ability to flow or deform continuously under the action of shear force. This branch of science deals with static, kinematic, dynamic aspect of the fluid. The study of fluid at rest is called fluid statics. The study of fluid in motion, where pressure is not considered, is called fluid kinematics. And the study of fluid in motion, where pressure is considered, is called fluid dynamics. Here, one thing is to be noted that for static fluid, shear force is always zero. And for examples of fluid, we can say air, water, steam, mercury, etc. Fluid properties. Properties are certain measurable characteristics that can be quantified. With the help of properties, we can identify the type of fluid. First of all, we're going to discuss density, or we can say mass density, which is denoted by rho. The density of fluid is defined as the ratio of the mass of the fluid to its volume. SI unit of density is kg per meter cube. Density basically represents the number of molecules in a given molecule of fluid. More the number of fluid molecules, more is the mass of the fluid. Hence, density represents the heaviness of the fluid, where we can say rho is equal to mass upon volume. Rho of solid is always greater than the rho of liquid and rho of gas, whereas the rho of H2O is 10 to the power 3 kg per meter cube, whereas rho of mercury Hg is 13.6 into 10 to the power 3 kg per meter cube, and rho of air is 1.2 kg per meter cube. And I would like to tell you one thing, in DMRC 2018 exam, the density, that is rho, the SI unit of density is being asked for the water, and its answer is 10 to the power 3 kg per meter cube. Let's move on to the second property of fluid, which is specific weight, or we can say weight density. Specific weight is defined as the force exerted by the fluid due to gravity per unit volume. Mathematically, it is defined as the weight per unit volume. Its SI unit is Newton per meter square. It is denoted by letter W, and it is equal to weight of the fluid upon volume of the fluid. Whereas M upon V is equal to rho, so we can say W is equal to rho G. The specific weight of water is 9810 Newton per meter cube. For mercury, it's 13.6 into 10 to the power 3 into 9.81 Newton per meter cube. For air, it's 1.2 into 9.81 Newton per meter cube. The point to be noted is density is an absolute property. It does not vary with location, whereas a specific weight is a variable quantity. It will vary with the location. Moving on to the third property is specific volume. It is defined as the ratio of volume of fluid to the mass of the fluid. It is denoted by letter S dot V, whereas it is given as volume of fluid upon mass of the fluid. A specific volume is also called as the inversely proportional to the mass density of the fluid. Moving on to the fourth property, that is specific gravity. Specific gravity is defined as a ratio of the density of the fluid to the density of a standard fluid. Standard fluid in case of liquid is taken as water, whereas standard fluid in case of gases is taken as air. Specific gravity basically shows us which fluid is heavier than water and which are lighter than water. So we can say Sg is equal to rho of fluid upon rho of standard fluid. If the specific gravity is more than 1, we can say the fluid is heavier than water. But if the specific gravity of the fluid comes out to be less than 1, then we can say it is lighter than water. Fifth, and one of the most important properties to be discussed, is viscosity. Viscosity is defined as the property of a fluid which offers resistance to the movement of one layer of the fluid over another. It is denoted by letter tau, and it is directly proportional to the velocity gradient, that is du upon dy. So we can say tau is equal to nu du upon dy, where tau is the shear stress, du upon dy is the velocity gradient, and nu is the coefficient of dynamic viscosity. Sixth property of fluid is kinematic viscosity. It is defined as the ratio of between the dynamic viscosity and the density of the fluid. It is denoted by a letter V, which is given by viscosity upon density, that is m upon s. Kinematic viscosity is also known as Stoke, where 1 Stoke is equals to 10 raised to the power minus 4 meter square per second. And I would like to tell you one thing, that this question, how much 1 Stoke is equals to, has been asked in DMRC exam for Junior Engineer Mechanical in 2018. One of the most important laws in fluid mechanics is Newton's law of viscosity. It states that the shear stress, that is tau, on a fluid element is directly proportional to the rate of shear strain. The constant of proportionality is called the coefficient of viscosity, that is tau is equal to nu du upon dy. Fluid which obeys the above relation is known as Newtonian fluid. The fluid which do not obey the above relation is called non-Newtonian fluid. And the examples are H2, water, mercury, and air. We can further understand it by the graphical representation, where on the y-axis it is mentioned to be shear stress, that is tau. On x-axis it is the velocity gradient, that is du upon dy, and A is marked for the oil, B is marked for water, and C is marked for air. All those fluids are Newtonian fluids, for which viscosity is constant with respect rate of deformation, and thus fluid are represented by a straight line passing through the origin having constant slope, and that slope is called the viscosity. Coming to another topic, that is variation of viscosity with temperature. In case of fluids, the main reason of viscosity is molecular bonding, and with increase in temperature, the molecular bonding breaks and viscosity decreases. In case of gases, the main reason of viscosity is molecular collision, and with the increase in collision, the temperature increases and hence the viscosity increases. For liquid, if we increase the temperature, both the dynamic and kinematic viscosity decreases. But due to cohesive forces in gases, both the dynamic and the kinematic viscosity increases. The viscosity for gas is directly proportional to under root of the temperature. It is one of the important formulas which is usually being asked in the competitive exams. We can understand it by the relation and or by putting it in the graphical representation also in viscosity versus temperature graph. And as you can see, for liquids, as the temperature increases, the viscosity is decreasing. But in case of gases, As the temperature is being increased, the viscosity of gas is increased. But in case of pressure, there is no appreciable effect in case of viscosity. So guys, that was it for today. We will be back with new videos on fluid mechanics. Till then, stay tuned and don't forget to like our video and subscribe to our channel and hit the bell icon to get the latest notification of our new video.